today I'll give you a workshop of how self protocol works and some new feature we've launched that you might have heard about already. But yeah, this is an overview of what today's workshop is. So I'll talk a bit about self, why we need self in the first place, the bounties, and the code example, like probably a live demo. Yeah. So what's before we talk about self, what's the issue with existing KYC solutions? What they do is they take your data and then they store it insecurely. Like if you heard of the T hack, they had a public AWS a Firebase bucket. So all your data was like stored there, and then it got leaked because it was public, and yeah, it was pretty bad. So it's also like pretty bad user experience because someone has to manually verify your data. It's going to take days, and then it's very privacy invasive, and it's making you uncomfortable in general to log in with any third party app. So Self is not a KYC provider. What we plan to do is eliminate KYC where it's not needed. So why would you just to verify that you're above 18 send your entire Aadhaar data to some website and so they can store insecurely and then later get hacked? So yeah, that's where Self comes in, where you can have um, where you can reveal data about yourself without really revealing anything. So how we do is, so yeah, why how so when we released, we started off with passports. And why would we use passports? So one thing is they are difficult to obtain and they are unique per the issuing country. So there's a trust assumption on the government, but if you don't trust the government, then there's like bigger issues. But yeah, so and there's also machine readable, so it's easier to work with. Like if you see the bottom part of your passport, it has a machine readable zone, and what you can do is it's pretty easy to work on top of that and integrate that into automate that existing system. And you would also get like one nullifier. So nullifier is a unique identity for unique hash, I would say, for your identity. And it provides a good way to tackle Sybil resistance. So previously what people did was to do Sybil resistance, you had to bring in some capital, and like you had to stake some amount or you had to do some proof of work. But like you can also use it using identity and have some build it on top of an existing trust solution that is identity solution that's like from the government. And not only that, not only do you tackle Sybil resistance, you can also disclose certain facts about yourself. So in a privacy preserving way, you can choose to only reveal your name in a verifiable way, and only that gets revealed and nothing else. So a name is not that useful. So there's other attributes such as date of birth, issuing state, nationality, gender, and so on. And not only that, we also have some custom claims that you can integrate into your SDK, such as you have to be above a certain age or you're not from a set of countries, which if you're using the existing SDK, it's like a max of 40 countries you can set, and you're not on the OFAC list. So the OFAC list is a US sanctioned list that has a list of all the criminals. And what you can do is if you need some compliance in your app, then what you can do is you can just add this check and see if a person is not like a criminal inside this list. And yeah, so not only passports, we also support Aadhaar now. So before passports had like 1.1 billion users, but Aadhaar is like 1.4 billion, and you can target almost every Indian who has an Aadhaar, which is like almost everyone. And there's also biometric IDs that we support. So these are a bit of different thing, and it's mostly issued in the European countries and some other countries like Ghana and Argentina. But it's still a verifiable solution for identity. And how does it look like? So we have two steps inside the self protocol. So the first thing is registration. So what you do with registration is register yourself in an on-chain Merkle tree. And what this does is, make sure that you don't register twice and so on. And so it's kind of similar to Tornado Cash or like Semaphore from PSC if you've heard of either protocols. The thing is, first you register into some anonymity set in an on-chain contract, and then you prove you're part of that on-chain set when you do a disclosure. So disclosure is basically one thing is proving that you're a legitimate person, like you got registered inside this on-chain Merkle tree. And the next thing is you reveal some attributes about yourself, and you can do it So the first registration step verifies your entire document data. And when you disclose, you don't have to verify it again because it's already registered on chain, and it's like much more efficient. And this is different from other passport protocols that would do the registration and disclose step in a single step. So that's kind of dangerous because you can link your revealed attributes to your nullifier, which is trackable by the government and so on. And yeah, how does the registration flow work? So you have this passport or your Aadhaar data that's stored inside your mobile app, and you also have a secret that is based on your biometric data, like your passkey, and we store this inside the cloud backup. And what we do is we send this encrypted data to a TE that would generate the proof and submit a proof on chain. Why are we using TE? Because some of our circuits are like the Z keys are 5 GB big, and they take like even 3 minutes just to prove like a brain pool 512 circuit, just um just like a single circuit. So it's pretty hard to do client side, and we're using Circom and Groth16 inside this process, which is like the only ZK stack that has been audited extensively. And the disclosure is simply this is what you would integrate in your app mainly. So the registration step is done by the self app, but the disclosure is something you as an integrator needs to work with. So you have a QR code or like a deep link if you're using a mobile app, but if you're building a web app, it's a QR code. And what the user experience would look like is you create a QR code with certain attributes you want to reveal, certain claims you want to check, and the mobile app, you can scan this QR code with your mobile app and then create a proof and submit it on chain. So you can either submit it on chain. This is where the on chain SDK part comes in, where you write a contract that verifies your proofs and works on top of that data. Or you can do it inside a backend verifier that would verify the proof inside a Node.js server. But yeah, in general, for ZK proofs, you would want to verify it on chain because there's a trust assumption on the verifier if you do it in the backend. Like the verifier can censor some proofs and not accept some proofs, so you would want to do it on chain where there's some consensus on what happens. And moving on to the bounties, we have for on chain we have for the first prize 5K followed by 2.5K and 1.5K. So these are the prices we have for on chain SDK. So the reason we focus so much on us on chain SDK is like what I said before, which is it's a more trustless form of verifying your proof. Like if you do it in the backend, you can always choose to not accept a proof, and that's not like completely um, honest. So yeah. So that's for on-chain, and for off-chain, we offer $1,000, and yeah, it's you can see it's like much more for on-chain. And moving on to the code examples, I have a demo prepared here. So to just to show you how it works in general. So you can see this is the QR code, and this QR code has data about what you would want to um, disclose. So if I go inside the app, um, I don't know if you can see it. You can see what I'm disclosing inside this disclosures field. I'm only proving that I'm at least like 18 years old and I'm not in excluded countries, which is the United States. And yeah, this is like on mock. This is like a mock Aadhaar that I'm going to use, but the idea is so I'm just going to use the self app right now, and yeah, you can see there's like a Aadhaar document that I have already on me, and if I'm just going to scan this QR code, which would the app would ask me that I'm going to reveal these properties about myself, and then I'm just going to consent that these properties are going to be revealed eventually. So yeah, it's important that you take a look before you reveal stuff you don't want to reveal. Yeah, and this it's going to take a while to load, but meanwhile, while that happens, I'll go over how it works on chain. For the QR code SDK at least. So you have this a self app builder object that has info about your app, like your version it should be 2 and the name and the scope. And the scope is eventually used to calculate the nullifier. and then there's like user ID that you want to associate a given identity to a particular user. So you can either make it a Ethereum address, or you can use UIDs. And here I'm using like a dummy 0 address here. But yeah, I think, and the endpoint is like staging because I'm verifying it like on the staging network on like Celosepolia. So I'm just holding to verify my um, document basically. So it's proving now. If you can see it, I'm not sure. And it verified, and it takes you to this page that you're now verified. So if I disclose with like a country that has, if I disclose with a passport that is from the US, and I set that the country, excluded country, is like US, then it's not going to work because the proof won't be generated because you're from US and you don't want that. And that is from, so that's the self app builder basically, and then you put that inside your QR code, which is pretty simple. And that's all you have to do on the front end SDK. Just define a config about your app, and then store where you want to verify the proof, what type of user ID it is, and some data that you want to um, as pass in to your contract to do some custom logic that you would require later on. And yeah, that's it for the on-chain QR code. And for the contracts, it's a simple contract, and the main idea is extending this thing called SelfVerificationRoot. And there's basically two, it's an abstract contract, so there's like two methods you have to override. One is the custom verification hook. So what this does is, once your proof is verified, what do you want to do with it? So we have a relayer system. So we have a relayer because um, well, if all proofs are sent by the same relayer, it's hard to link it to the single person. So that is one reason why we use a relayer. And um, yeah, I'm just doing a simple event. I'm just emitting this event once the proof is verified and I get all this data. So you can see inside this, there's a bunch of stuff that has been revealed, and yeah, you can work on top of that in your hook. And there's also the get config ID. So you notice that in the front end, we had like a certain claims that we wanted to verify. So this was minimum age and the excluded countries. So this config has to exactly match your off-chain or on-chain config. These two should be the same because the claims you are testing should be the same. And it's one way of enforcing that the same config is used. So you can see I'm setting the config in the constructor here. You can set it like inside a different function. And when deploying this thing, I am, yeah, I'm setting that it's older than 18, and the forbidden countries should be United States. Like, that's all I would have to set inside the contract. And yeah, so it's just two functions that you have to override, and it can be as simple as this, and you can have like a bunch of other logic inside your custom verification hook. So that would be off chain. And yeah, so that is some code example. So this is the workshop repo. If you want, you can just clone it and set the .env, like deploy the contract and set it inside the .env, and it's going to work. If you want to quickly test out how self works, so the app directory has the front end and the QR code stuff, and the contracts directory has like this proof of human Solidity contract that you can take a look at. Um, Yeah, so you can also visit our docs, and we also support multiple different ID documents. So the format of the disclosed data is not going to be the same. For example, in passports, you only use the first two, like the last two years. Like basically, if it's 2022, it's just going to have 22 inside the passport, and we can't extract the year. It could be 1922, it could be 2022, and yeah. So but like in Aadhaar, you have the full year. So if it's 1984, it's going to just stay 1984, and it's something to watch out for. And we have documented that inside our docs. Like there's an Aadhaar specification document, and yeah. So yeah, that's all for my talk. And you can start us on GitHub and go to our website. But does anyone have questions for me for the self SDK in general, or yeah? So previously you had to use this tools.self.xyz thing where you had this scope, you would set the contract address and then the scope seed, and then it would hash it, and then you have to set the config ID. So from like this update, you don't have to do that. So it's going to natively happen. You can programmatically set the verification configs. Like if you saw here, in deploy proof of human.sol, I'm just setting this config. I don't have a config ID thing. I'm just setting it should be older than 18, forbidden countries should be so and so, and the OFAC is enabled. And inside the contract, like in the constructor, you can see I'm formatting into some more readable format for our Onchain hub, and then I'm just setting that inside. You can see the verification config ID is still a thing, but like you can do it programmatically. So you don't have to set it again. And you can also see the scope is now a string instead of like a UN256 dummy scope that you had to set. So the contract, like the self-verification root constructor, is going to handle all of the scope generation by itself. So you have to put the contract address in lowercase. That's the only thing you have to watch out for. But yeah, yeah. But you don't have to use tools.self.xyz anymore. Yeah, yeah, yeah. Any other questions? No. Okay. I guess we can wrap it up. You can find me at the booth if yeah, and we'll be there like yeah throughout the whole hackathon. Thank you.